In order to determine graphically what the order of the reaction is for the decomposition of dinitrogen pentoxide, we need to understand what the graphs are going to look like dependent on the reaction being zero, first order, or second order. In the case of a zero order reaction, if we were to plot the concentration of the reactant as a function of the rate, or plot the rate as a function of the concentration, we should see that the rate will be independent of the concentration. If it were second order, if we were to plot the rate as a function of concentration, the rate would end up being a square function of the concentration, or more specifically, the rate is going to stay constant, and on this one, the rate is going to increase as an increase in concentration, but not in a linear fashion, but in a square function fashion, like in an x squared fashion. If the reaction is first order, then if we were to plot the rate as a function of concentration, we should see a linear increase in the rate, where the slope ends up being the rate constant. Rate would be, if you double the concentration, you double the rate. If you plot rate as a function of concentration, the slope is the rate constant. So that's what I did. I took all of the data and I plotted the rate as a function of concentration, and sure enough, I got a linear relationship between the rate and the concentration, so I know it's first order. Now that I know it's first order, in Excel I can ask or click on this box that displays the equation, and I will see the equation of the line has a slope of 1.068 times 10 to the negative 5. So because it's first order, and I know the slope is equal to 1.068 times 10 to the negative 5, that is the rate constant. This is how you would graphically determine the rate constant.